Hello world, welcome to NetMath and Tech Academy. In this episode or in the following episodes, we are going to learn how to solve a maze with Python code. We are going to apply backtracking algorithm to solve this. We are going to create a maze, um, design our maze with walls or blocks, and try and find a way around the blocks. Just to give you an idea as to what our target is, our program is going to be a pie game that looks like this, where the blue player tries to solve the maze and with the target of reaching the green box. All the red blocks are walls and we cannot, of course, go through them. So we are going to try and, as I said, approach this problem from the scratch and try and learn backtracking along the way. So what are going to be the steps we are going to do? We are going to first design and load the maze, and we are going to display the maze in the console window and solve the maze with manual arrow keys first, and then automate solving the maze, and then we will finally add the PyGame display. And as a last step, we will add some intelligence to the maze so it'll solve it much faster. But that will be the last step. So let's begin. Our first step is to design and load the maze. So our maze is going to be a 2 by 2 matrix. And how we are going to design the maze is through this text file. I have 10 columns here. So let me just copy paste them. And now we have 10 rows. So our maze is going to be a 10 by 10 maze. And we are going to fix 5 as our target. And let's say 1 as our player. So our target is for the player to reach the final target. And 2's are going to be the blocks. So there is a wall here, and let's say there is a wall here, and so on. So this will be dynamic and we can change it. So given our maze, how can we first load it? So we have to read this text file. So as I told you, our maze is going to be a list. So let's initialize the list and let's write our first function, which is load maze. And what it's gonna do is it's going to open this file maze.txt. So let's open maze.txt and let's read all the lines in the file. So for line in F, and each line has multiple characters, right? So we gotta break it. So for each character in line, we have to add it all into our maze. So we need to keep track of how many rows and columns are there. So let's start with 0 for now. So the number of rows we have is 0. Every time we go into a line, our row is gonna increase. We will first set our column to 0. So what we are gonna do is we are gonna load it into our maze. So for every row we find, we first have to append a empty list, and for every one of those empty lists we are going to append every character that we find here. So our column is gonna increase every time, and our row is gonna increase for every line. So let's print this and see how far we have got. And of course we have to call our function. Perfect. So it seems to be good. So we have our maze as a 2 by 2 matrix. The only trouble is we have the new line character also showing up as the last element. We want to ignore the new line character. So let's just add one if condition here. If C not equal to the new line character, only then we will add it into our maze. So now if I run it, we have a 2 by 2 matrix. Let's have this function return the maze and the rows and columns. Row column. Okay. So we can capture it in our values. And now let's print our maze, and let's also print our row and column, and let's make sure everything is working fine. Okay, we have 10 rows and 10 columns. But our maze, if we print it directly like this, it's not gonna look nice. So let's make a function to print the maze. So we will call it print maze. Let's pass the maze and the rows and the column into it. So let's start a loop for the row and then the loop for the columns, and let's print what's in the maze, the row, the column. And I don't want a new line at the end of every column. Rather, I want a new line at the end of every row. Okay, so now let's test our function. Let's print our maze and pass the maze row and column, and let's see how it looks. Okay, so we have 10 rows and 10 columns, and our maze looks like this. Let's change the values in here and add few more blockers and make sure that our logic is working fine. Okay, everything seems to be fine. So we have basically read whatever is in this text file and we have loaded into our maze 2x2 matrix or list, and we are now ready to solve the maze. So we have completed step 1 and step 2, and now let's go to step 3, where we simply want to read the arrow keys or the input from the user and solve the maze. So for that we need a while loop. Let's for now start with a while true, and we need to know which direction the user wants to move. So let's start with the input direction. Which direction? And we are going to give him the options of right, left, down, or up. Okay, good. So once the user enters his option, we want to move the player, which is 1, to the target, which is 5. It is not a bad idea to create variables for these or constants for these numbers. So in our case, a player is 1, the target is 5, and a wall is 2. Okay, good. So we want to also keep track of where the player is and where the target is. Only then we will know when we have actually solved the maze. So we, at any point, we want to know the player row and the player column, the target row and the target column. So how do we initialize it? We will do it in the load maze itself. In here, we can check if C is equal to player, then we can set the player row and the player column to the current row and the column. And if the character that we are reading from the file is actually the target, we can do the same. We can set the target row and the target column. And now this function has to return these values as well. So let's add them: player row, player column, target row, and target column. So that means we have to add them here as well: player row, player column, target row, target column. So let's now print all these values and check if everything is good. So now let's run this. We have error in line number 30 where the player row is used without being initialized. We are initializing it here. If C equal to player, player row, player column, target row, target column. Okay, so let's initialize these values inside the function as well and see if that solves the problem. Okay, good. But we do not get the correct values. Okay, now I know what the problem is. It's because in here we have all of them as strings, but we have the values here as integers. So I'm going to convert it into an integer because then all the comparisons and everything is going to be much simpler. So when we read it from the file, it is of course going to come as a, okay, good. So what did we have here? We have the player at 0, 0 and the target is at 9, 9. Why is it 9, 9? Because the rows and columns start at 0. So there are 0 to 9, which is 10 rows and 10 columns. So we will not need this anymore. So let's run this. It should still work now. Okay, good. Let's go to our maze.txt and try to change the value of a player. A player can be anywhere in the maze and see if it still works. Yes, now our player is in the 5th row, 2nd column, and our target is still here. Let's try to move our target somewhere up. And let's make sure everything is fine. Okay, good. So of course there are constraints here, like there can be only one player and only one target. I'm not taking the time to handle all those edge cases, but yeah, it is always a good idea to handle exceptions and handle those edge cases. To keep it simple, we are going to assume a proper valid input. Okay, good. Now we know where the player is and where the target is. Now let's go into the steps of how to move the player. When the user enters the direction, we want to move the player. Let's for now target a down movement. So how do I move the player down? Okay, let's call this function as move down. So I want to know what the maze is. I want to know the row, the column, and the current player row and the player column. So let's look at the maze. So what does it mean when the player goes down? That simply means his row increases, his column remains the same. So all we have to do is increase the player row by 1. And to keep it simple, let's say there is no block here. Now what happens when the player goes down? This value should become 1 because the player went down, and this value we can again make it empty, or we can actually mark it as the path in which we came from. We want to keep track of which way we came from. Only then we can backtrack, and also will not make the mistake of going the again or visiting the same node again. So we want to change the value to, let's say, 3, which is the path, and move the player forward. So let's go back again. So we are going to create one more type of cell here called path, which is going to be 3. So when you go down, all that we are going to do is we are going to mark whatever position the player is currently, which is player row, player column, that's the path. And since I'm moving down, my row will increase and my new position of the player will be changed like this. Now let's return all the values. So I need to return the maze, the row, the column, the player row, and the player column. Okay, I probably don't have to return the row and column because those values are not going to change. Okay, good. We only have to return these things. Now let's go ahead and check if move is equal to down. Then all that we are going to do is maze, comma, player row, comma, player column is equal to move down, maze, comma, row, comma, player row, comma, player column. And every time we make a move, we want to reprint the maze because we want to see the latest version of the maze. So now let's see what happens. So which direction you want to move? I want to move the player down, so I enter D. So now we see the new maze where the previous position is marked as the path and the new position is marked. Okay, good. So as we solve this problem, we will keep on be making more and more moves, and every time we are going to print the maze, we have to keep on scrolling our console window up and down. So every time before I print the maze, I'm going to clear my console, and for that I'm going to import the OS library And before I print the maze, I'm going to simply do a system clear. So that way now if I run it and if I move down, okay, I made the mistake of putting this in load maze. It should be rather in print maze. Okay, let's try this one more time. So I move down and I see I have cleared my console and I've printed the latest maze. So down is working fine, but right now I'm not checking if it is actually a valid move. Is there a block there? Am I going outside the coordinates of my maze? All those things have to be checked. So it's always a good idea to first check if it's a valid move. So what we are gonna do is to check if it's a valid move, we are gonna first write a function check move down. We're gonna keep the same input parameters. So what are the conditions we need to check? We need to check if the new position I go to, when I go down, what is gonna happen? My row is gonna increase by 1. If this new value is less than the row. So that way I'll ensure I do not go outside of the maze. Okay, that is one condition. What is the other condition? If this new position that I want to go to is not equal to a wall, because we don't want to run into a wall. And we also don't want to go into the same path where we came from. So let's add that too. And the new position I want to go to is not a previous path. Or to keep it all simpler, we can just check if it is a pre-spot for me to take. Okay, let's go with this approach for now. If everything is true, then I'm gonna return true. Else I'm gonna return false. Okay, good. So before I actually make the move, then what should I do? I should check if the move is possible. So I'm gonna check move down. So check move down. Only if it is a valid move, I can go ahead. So now if I stop and run this one more time, I move down. Okay, list index is out of range. Okay, so now let's see what is wrong here. +1. Oh, I understood the issue here. Okay, good. That was a really simple mistake we have done. We are supposed to use the player column here, and that was the problem. So let's now get back into where we were. Okay, sorry about that. So I moved down. I move down, I move down. So now we can see we are making the path. And now if I try to move down, I should not be able to because I'm hitting a block here. So nothing should happen. Okay, everything is working as expected till now. We have done one move. Mm, Now what we have to do is we have to work on the next direction. Let's say we want to move up. All we have to do is reduce the row. So if I simply change this to minus, that would be my move up code. So let's see if we can make this more generic. So I'm gonna call this move direction, and I'm gonna copy paste all of the code that we did for move up and add one more parameter here called direction. So all that we have to do now is if direction is down, we have to do this. If direction is, let's say, up, we have to do 0 minus 1. So basically we have taken our move down function and we have made it into a generic function so it can handle all directions. And if we go with the same idea of direction right is going to be changing the player column by 1, and our direction left is going to be reducing the column by 1. So we don't have to handle all the conditions here. All that we have to do is simply pass whatever move that the user enters here to the move direction function. But first we also have to write a generic function for check valid move. So let's call it check move direction. So again, the idea here is going to be same. Take whatever logic we have written already and try and make it generic. So all that we are going to do is calculate the new player position. So the new player row, let's first initialize it, and the new player column. If direction in which I want to move is down, then my new player row will increase. If direction that I want to move is up, then my new player row will decrease. Okay, good. If direction is right, now my new player column will increase. If direction is left, my new player column will decrease. So now that I have calculated the new position, all I have to do is check my new player position is less than row. The new player position and the new player column is actually an empty spot, and my new player row never goes less than or never goes less than 0. I cannot go negative, and I have to check the same for my new player column as well. it cannot go less than 0, and it should also be, it's actually greater than 0. It should always be greater than 0. And my new player column should always be less than the total number of columns. If all these conditions are true, then it is a valid move. So now let's check if everything is working fine. So all that we have to do is change our check to this and pass whatever move the user entered here, which will go into the direction parameter, and we will do it to check. So now let's see if everything is working fine. So now I should be able to move down. Something is failing. So let's see what is wrong. It has to be greater than equal to 0. Greater than equal to 0. Of course, it can be equal to 0 as well. So now let's check that one more time. Move down. Yes, move right. Move right. Move down. Move left. Move down. Move right. Move right. Move up. Right. Down. 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 Okay. Now all the directions seem to work properly, and we can also see that our path is being marked properly. There is one problem here. I'm not able to go to the target here because in the check condition, you are actually checking only for 0, but it can also be the actual target that we want to go to. So let's also put target here, because I can of course reach my target. Okay, so now let's see if you are able to solve the problem. The maze, I move down, I move right all the way, and then I move down, and I have reached my target. But when I reach my target, the loop is not breaking. So let's add the condition to check if we have reached our target and break the loop. If the player row is equal to the target row and the player column is equal to the target column, at this point we can say success and we can break the loop. So let's quickly check if that is working. I'll put the target right next to me. So let's stop and run this. Now if I move right, then I have solved the puzzle. If I move down, move right, and move up, I have again solved the puzzle. So that's good. So going back to our steps, we have solved, or we have completed steps 1, 2, and 3. And in the next episode, we will see how to proceed with this, how to automate this so we can use backtracking and automatically solve the puzzle. And then let's make a PyGame display in the future episodes. Thank you friends for listening patiently to this long video. We'll meet again in the next episode of maze solving. Bye world.